Now, say this time I come to the premise of a conductor. This time I come to the premise of a conductor. Okay, this is a conducting body, arbitrary shape. This is a conducting body of an arbitrary shape. There is an enclosed volume, there is a surface of this. Immerse it in an electric field. Immerse it in an electric field, external electric field. Okay? This is an external electric field to which it is exposed. What does the conductor have? It has an unlimited store of mobile charges or charge carriers, charges or charge carriers, right? A non-conductor will not respond to the presence of an electric field, because even though it has charges, those charges are not allowed the liberty to migrate inside, right? But a conductor gives the charges the liberty to move as per their own sweet will, right? It has an infinite store of charges. Now, so positive charge carriers will move in the direction of the electric field. Yes or no? Positive charge carriers would move in the conductor, will move in the direction of the electric field, and therefore they would want to settle on this surface. They would want to settle on the surface, whereas negative charge carriers would want to move opposite to the direction of the electric field. Negative charge carriers would want to move opposite to the direction of the electric field, leaving this surface with a negative charge. Yes or no? This charge, which responds to the external electric field, has not come out of any outside agency. It is only a charge redistribution. It's only a charge redistribution for charges that are already prevalent inside this body, right? And this redistribution of charges based on an external electric field presence is called induction. This is induction. These are induced charges. These are induced charges. These are induced charges. All right. So positive induced charges, these are negative induced charges. Now, so there is a charge separation that takes place inside the body. There is a charge separation that has occurred inside the body. Yes. Now, because of these charges, forget the external electric field. If you theoretically imagine a unit positive charge placed here, it will experience repulsion from this and attraction towards this. That means inside the body, there is an induced electric field going from right to left. There is an induced electric field. There is an induced electric field going from right to left. Yes or no? External electric field is from left to right. Induced electric field, because of the charge separation, is from right to left. Right? Yes or no? Now, as there is more and more charge separation taking place because of the external electric field, E induced will grow in stature. E induced grows in stature. Right? Eventually, at some point of time, E induced will exactly counter E external. E induced will exactly counter E external, right? This charge separation will grow to such an extent that the external electric field will be completely countered by the induced electric field. Yes or no? So eventually you would expect at some point the electric field at any point P, which is the resultant of the external electric field plus the induced electric field, to become 0. yes, I will. देखो बेटा, external electric field है, positive charges will respond and move on this side in the direction, leaving behind negative charges, or rather you can say, if it was only electrons, it'll be like electrons moving in this direction, leaving with net positive charge here. ये समझ गई? इस charge को क्या कहते हैं? Induced charge कहते हैं, right? Now because of the induced charge alone, think of it, क्या होता है? There is an electric field at P. There are two electric fields now. Originally, when there was no charge separation, there was only an external electric field at P. Now at P, there is not just an external electric field, there is an induced electric field. क्यों है बोलो induced leftwards क्यों है? Because if you place a unit positive charge here, then because of this charge separation, that positive charge will experience a leftward force, attraction towards this and repulsion from this. है ना? अब देखो जैसे जैसे charge separation बढ़ता जाता है, this does not change, but this grows in stature. More the charge separation, greater is the value of the induced electric field. So at some point of time, this induced electric field will exactly neutralize this external electric field, right? That means the net electric field at P eventually has to become zero. And this is for any P inside the body. This is for any P inside the body. Yes or no? This will happen. This will happen. And of course, you know, even though it took me a few minutes to tell you that this is happening and that is happening, it happens instantly in the body. The time taken for it to take place is instant. It doesn't take this long like I communicated, right? So don't be misled by the gradual communication I made to you. This process is instantaneous, almost instantaneous, right? So, which means what? And this P is in the meat of the conductor. This P is in the meat of the conductor, yes or no? If the electric field at any point P is zero, it means there are no net electric lines of force at P. No net electric lines of force at P. Yes or no? That means no electric line of force can be present in the meat of the conductor. No electric line of force can be present in the meat of the conductor. The meat of the conductor under electrostatic conditions. Write down. The meat of the conductor under electrostatic conditions. The meat of the conductor under electrostatic conditions will be unconditionally a region of zero electric field. Will be a region of zero electric field and therefore constant potential. Clear? They would be, please understand that there is a conductor by its very definition is almost like an infinite store of charge, and if I cross E external beyond a certain value, that there cannot be enough charge separation to counter this, you know, then this E external is not that we encounter in real life. This E external perhaps could be, let's say in a lightning where, you know, 50, 100,000 volts of lightning is produced. Okay, so we are not talking of those situations anyways, right? We are all only talking of electric fields for which there is enough number of charges that can counter those. We are only talking of those, right? Can I wipe this off? So no matter what I do to a conductor, whether I assign charge Q to it or I expose it to an electric field, the meat of the conductor will always be a region of zero electric field. The meat of the conductor will always be a region of zero electric field under electrostatic conditions, right? This is a conductor then. To begin with, an isolated conductor. Now, So this is an isolated conductor. And a charge q is assigned to it. And a charge q is assigned to it. Then this charge q must get distributed in a manner that it will produce zero electric field in the meat. The meat of the conductor, you would expect, has to be a region of zero electric field. What is it that I want? I want this region to be a region of zero electric field, constant potential. This is what I want. The charge q will get distributed accordingly. The charge q will get distributed accordingly. And we understand that the only way this charge q can get distributed to produce zero electric field and u equal to constant is by getting distributed on the surface such that sigma inversely proportional to r, right? To produce this state, q must get distributed on the surface as per the guidelines of sigma inversely proportional to r. Such is how it must get distributed. Non-uniform surface charge distribution. This is a non-uniform surface charge distribution that takes place because r is different, right? So, you know, if you see a sharp point is low value of r. Whenever you see a sharp point, that is low radius of curvature, and that will be high sigma. And when you see a gradual region like this is like low r. This is like low r, low value of the radius of curvature, sigma high. This is like this sharp corner. So you will find charge, sigma surface charge density less here, right? But if you see a sharp corner, then this point is like low r, low radius of curvature. A sharp point is like a very low radius of curvature, but sigma high. I'm sorry, this is, I'm so sorry. Kaan pakad ke maafi. This is high value of r and sigma low. I'm so sorry. I stand corrected. This is high value of r but low sigma. This is low r but high sigma. That means there is greater charge concentration at sharp points compared to gradual points, right? You'll find more charge per unit area surrounding this point compared to this region, right? Because of the differential radius of curvature in those regions. So then, for sure, the charge q will get distributed to produce zero electric field inside this volume. Now this happens. And the only way it can produce zero electric field inside this volume is if sigma is inversely proportional to r. That's the only way it can produce zero electric field here, right? So far so good. So far so good, yes or no? Now, let me build it up. So, one thing that's an outcome of this is charge q will not reside in the meat of the conductor. No net charge can reside in the meat of the conductor. 1. 2. The electric field in the meat of the conductor under electrostatic conditions must be 0. Right? Charge will not reside in the meat of the conductor. Net charge will not reside in the meat of the conductor. The meat of the conductor would be 0 electric field and constant potential. And the potential inside is the same as potential on the surface. The surface is an equipotential surface. EPS is an equipotential surface. This is EPR, equipotential volume or equipotential region. And potential on the surface will be potential inside. That fact remains permanently true. Let me know if I can wipe this off. Hmm? So there is charge q given to this conductor, this charge q given to this conductor, and it assigns itself on the surface with sigma inversely proportional to r to produce zero electric field in this volume. Now what I do is, this conductor which has been assigned this charge, okay, which has got distributed as per sigma inversely proportional to r. Now this very charge distribution is exposed to an external electric field. Is exposed along with this charge distribution, it's exposed to an external electric field. Now look at a point P. Because of this charge distribution that was there on the surface, sigma inversely proportional to r, what happened? The electric field at P was 0. If sigma was still inversely proportional to r, please listen to me. If sigma was still inversely proportional to r on the surface despite an external electric field, then at this point P, there is field because of two things. Charge on the surface, E because of the charge on the surface, E because of the charge on the surface, plus E external. That's a net electric field at P? Yes or no? Now, despite application of an external electric field, if this continued adamantly to be the charge distribution on the surface, then this will become 0. This will become 0. That means then there will be a non-zero electric field at P. Then there will be a non-zero electric field at P, yes or no? If sigma continued to be inversely proportional to r on the surface despite this external electric field imposing, then this part will still remain 0 and there will be a non-zero electric field at P, which is E external. Right? But that cannot happen. The meet of the conductor at all times, for all applications, has to be a region of zero electric field. Has to be a region of zero electric field. That means sigma will no longer be inversely proportional to r, because if sigma was inversely proportional to r, this component will become 0 and there will be a non-zero electric field at P. So then, if this happens, then sigma changes. Sigma changes. Surface charge density, sigma changes on application of an external electric field. It will no longer be sigma inversely proportional to r. For if it was that, what would happen at P? Sigma non-zero electric field at P will be generated at P. Right? In fact, the charges then consolidate their efforts. Collectively, they have a new distribution so that the charges on the surface, so that at the point P, I'm just drawing it separately, it's not a point P outside, so that at this point P, the external electric field is to the right and the field because of the charges on the surface will be to the left. So that this counters this completely. This is the new field at P. Because of the surface charge density will be E surface, E because of the surface charges to the left countering E external. But that means if this charge distribution is producing non-zero electric field at P, it cannot be inversely proportional to R. It cannot be inversely proportional to R. That means there is a new distribution of charge that occurs on the surface. The new charge distribution will connive, will collectively come together to produce new surface charge distributions, to produce an electric field at P that will exactly counter the external electric field, because what's the basic premise? The basic premise is that the electric field at P should be 0. Whether it's sigma inversely proportional to R that can cause the electric field to be 0 at P, or some other charge distribution on the surface that can counter E external so that the electric field at P should be 0. One way or the other, what is more important? The electric field in the meat of the conductor should be 0. If there was no external electric field, then it was the responsibility of the charge on the surface alone to produce 0 electric field at P. Right? But if there is an external electric field, the charge on the surface has a new responsibility, not to produce 0 electric field at P, but to produce an electric field that will exactly oppose the external electric field. Right? Now it has to produce a non-zero opposing electric field that will produce net 0 electric field at P. So two things, I repeat one more time. One, no charge can reside in the, no net charge can reside in the meat of the conductor. Two, under all conditions, no matter what the distribution, no matter what the external electric field is, the electric field in the meat of the conductor must be 0. There cannot be residence of any electric lines of force in the meat of the conductor. There cannot be residence of any electric lines of force in the meat of the conductor. Yes or no? Huh? Huh? Please ask, yeah. So rolling thing. Huh. But on a non-conducting surface, right? Those charge distributions don't get affected by the external electric field. So what you want to say is, there is a ring. Say on this portion, there is one kind of charge distribution. On this portion, there is another kind of charge distribution, right? And there is an external electric field. Okay, then? Say where? Say for example here, what would be the electric field? Okay, so think about it. Sit down, please sit down. See one thing. For this quadrant, right, there is going to be an electric field like this because of this positive charge. Because of this negative charge, again there is going to be an electric field like this. They two add up, right? And at this point there is an electric field because of the E external. The resultant field will be because of this and this, E external, and field because of this, you realize from symmetry considerations, will be like this. Field because of this at this point will be also like this. They add up. The external electric field is like this. So the resultant would be the net of these two. Absolutely. Absolutely. Was that your question? Is this addressed? Okay. Okay. Now, so like I said, if charge Q is given to a conductor, isolated conductor, it will distribute itself as sigma inversely proportional to R to produce 0 electric field in this region. Right? If there is an external electric field, E naught, that is applied, then gets redistributed. The charges come together, they talk to each other, and they decide what must be the revised distribution mode to produce zero electric field, because now together they cannot produce zero electric field here. Therefore, it cannot be sigma inversely proportional to R anywhere, on the surface anymore, right? So it has to be now such that at any point E naught has to be countered. Such must be the new distribution mode on the surface. That means when a conductor on which charge resides on the surface is exposed to an electric field, the charges on the outer surface, they combat this external electric field. Charges on the outer surface combat this external electric field and don't allow infringement of electric lines of force in the meat of the conductor. The meat of the conductor is a protected region, right? It will not face the heat of any net electric lines of force, right? So the charges on the outside handle this situation by themselves if exposed to an external electric field. Now, charge was distributed on the surface. Charge was distributed on the surface as per sigma inversely proportional to R, and it produced zero electric field here everywhere in the meat of the conductor, right? Now, if in the meat of the conductor I scoop a meat out, this was the meat of the conductor. So now this is my revised meat of the conductor. I have generated what is called a cavity. Now, one thing, if I produce a cavity, if charge was distributed as per sigma inversely proportional to R, it will produce zero electric field everywhere inside this. Now, if I excavate a cavity from this, then let me tell you, not just in the meat of the conductor, but in the cavity also there is going to be zero electric field. This distribution of charge then, everywhere in this region, whether there is meat or there is cavity, it will produce zero electric field. So now electric field is zero in the cavity as well as in the meat. It will be indiscriminate. It will be indiscriminate about this. Now, you expose it to an external electric field. What is it that I have said? Okay. The charges on the outer surface will prevent intrusion of external electric field in the meat and also inside the cavity. There would be no electrical infringement inside the cavity or in the meat. It's just that these charges like soldiers on the war front, they will remain on the war front but will reallocate themselves on the surface, to combat the presence of E naught, so that there is no electrical line of force that is present in the meat or in the cavity. Right? This therefore is shielded. This region is shielded from all external electrical influences. Right? Which means if you were sitting inside this, and there was inside the cavity, shielded by a metallic or a conducting meat, and there was a lightning, which essentially is high electric field, trust me, you are safe here. Because these charges will together combat the external electric field and will not allow intrusion of external electric field to get inside the cavity. So you will not get electrocuted. You will not get electrocuted. No matter how this E naught is, you will not get electrocuted. You are electrically safe. Inside the cavity you are electrically safe. You are electrically shielded. Agreed. But are you safe? You are electrically safe, you are electrically shielded. But are you safe? That's a question to answer. You know, do you understand what I'm saying? Yes. You are inside this cavity and there is an external electric field in the form of a lightning. Electrically, nobody can touch you here because the charges on the surface will combat that. But still, are you safe? You're not safe. What would happen is, this lightning will produce tremendous amount of heat here, and you will become paneer butter masala here. You will melt away to glory. Huh? Yes, ready for consumption. Right? So you are electrically shielded, electrically protected, but heat will melt you. Right? So that's, this is really the idea of what is referred to as an electrostatic cage. If you have heard of this is like an electrostatic cage. It only gives you electrostatic protection, electrostatic shielding, but doesn't guarantee shielding from all other effects. But electrical effects will not dawn upon you. Clear? No. कुछ नहीं होगा यार, इलेक्ट्रिक फील्ड लाइंस तो नहीं होगा, ये मेल्ट कर जाएगा यार, हीट जनरेट होगा, ये मेल्ट कर जाएगा, यही तो होगा, गर्म हो जाएगा, मेल्ट भी नहीं करेगा. सोचो इसका टेम्परेचर हो गया 850.1 डिग्री सेंटीग्रेड, छू के देख उसको, सारा गर्मी निकल जाएगा. हाँ वो सिग्मा ऑब्वियसली होगा, तभी तो इलेक्ट्रिक फील्ड जीरो होगा, तभी तो तुम शील्डेड हो गुरु. कुछ प्रिंसिपल नहीं चेंज होगा. ठीक है बेटा, समझ रहे हो या कंफ्यूज हो गए हो? सब बात समझे हो ना सब कोई? हाँ, नाउ your attention please. So I know by this time cliched, but let me repeat. 1, no net charge can reside in the meat of the conductor, and at any point in the meat the electric field will be 0, and sigma inversely proportional to R on the surface will produce 0 electric field everywhere inside that because of that distribution, and that's the only distribution that can produce 0 electric field anywhere inside. All right? अब देखिए आप. So this time I have a conductor. This is a conductor. And this conductor has a cavity. This conductor has a cavity. This conductor has a cavity. This is the meat and this is a cavity. I place a charge Q somewhere inside the cavity. Charge Q inside the cavity. Now, let me look at a Gaussian surface surrounding the cavity, very close to the Gaussian surface surrounding the cavity in the meat of the conductor. This is my Gaussian surface. This is my Gaussian surface surrounding the cavity, just surrounding the cavity. Gaussian surface just surrounding the cavity. Now every point on this Gaussian surface is what? In the meat of the conductor? What must happen? E must be 0 at every point in the meat of the conductor. E must be 0 at every point in the meat of the conductor. Right? So what's the flux through the Gaussian surface? Flux through the Gaussian surface. Flux through the Gaussian surface is 0 because E is 0 at every point on the Gaussian surface. E is 0 at every point on the Gaussian surface. Flux is 0. Now if the flux is 0, net charge enclosed must be 0. Because, right, flux through this must be net charge enclosed by epsilon naught. Right? Flux means net charge enclosed by epsilon naught. Right? That's Gauss's law. That means net charge must be 0. It means net charge must be 0. That means if there is charge q, there must be charge minus q somewhere. If there is charge q, there must be charge minus q somewhere. Where would that minus q be? It will be on the cavity walls. There would be charge minus q on the cavity walls. This means a charge minus q, which is an induced charge. Which is an induced charge. Because this whole meat was electrically neutral. Right? Charge minus q must have been induced on the cavity walls. This charge must be minus q. Right? Yes or no? So if there is a charge q in the cavity, it will induce what? A charge minus q on the cavity walls. Huh? Ab ye dekho. The meat was electrically neutral. The meat was electrically neutral. That means if there is minus q, then the rest of the conductor must have charge plus q. But that charge plus q cannot be in the meat of the conductor. It must therefore find solace on the surface of the conductor. Yes or no? I repeat. This q inside the cavity has done what? It has induced minus q on the cavity walls. It has induced minus q on the cavity walls. Arey yaar, ye minus q aaya kahan se? This was electrically neutral. That means the rest of the conductor must have charge plus q. Rest of the charge, so that there is electrical neutrality preserved. Right? Now that means this entire region must have charge plus q. But that plus q couldn't have been in the meat of the conductor. Where will it find a position? On the surface. That means a charge plus q gets designated to the surface of the conductor. A charge plus q gets designated to the surface of the conductor. This is what happens. Yes or no? So there is, if a charge q is kept inside a cavity, it induces charge minus q on the cavity walls, and there is compensating charge plus q on the outer surface of the conductor. There is a compensating charge plus q on the outer surface of the conductor. How about it? No confusion? Rushil, you have a question now? Naina? Now, having understood this, can I just wipe this off and draw a fresh figure if you're done? Clear? So inside the cavity a charge plus q was placed. What happened? A charge minus q was induced on the cavity walls. A charge minus q was induced on the cavity walls, and on the outer surface of the conductor there was a leftover charge plus q. Plus q, which is the leftover charge. This is leftover charge plus q. See, leftover in the sense, देखो बेटा यहाँ पे तो कोई चार्ज था नहीं ना, कैविटी वॉल्स में माइनस क्यू हुआ, नेट चार्ज इसमें जीरो होना चाहिए था, तो लेफ्ट ओवर क्या होना चाहिए? प्लस क्यू होना चाहिए ना, ताकि नेट चार्ज मीट में जीरो रहे. नेट, it was electrically neutral. This conductor was electrically neutral. Moment I place a charge plus q inside the cavity, it induces charge minus q on the cavity walls. पर ये minus q कहाँ से आएगा? So that there is plus q in the remaining conductor. पर वो plus q, that's a leftover charge. पर वो plus q meet में तो reside नहीं कर सकता है, तो वो outer surface में चला जाता है. It finds positioning on the outer surface. कहाँ चार्ज है? कैविटी में चार्ज है. कंडक्टर मतलब ये पार्ट हुआ, ये इलेक्ट्रिकली न्यूट्रल है अभी भी. ठीक है, कैविटी के अंदर एक आइसोलेटेड चार्ज हम किसी तरीके से रख दिए. नाउ अगेन, if you look at any point P inside the conductor, if you look at any point P inside the conductor, in the meet, if you look at any point P in the meet of the conductor, the net electric field at P is going to be because of three charge distributions. Because this plus q inside the cavity, minus q on the cavity walls, and leftover plus q, leftover plus q. E because of plus q inside the cavity, E because of minus q on the cavity walls, and E because of plus q on the outer surface of the conductor. That will be the net electric field at P, right? Clear? These three vectors together produce the net electric field at P. But P is a point in the meet of the conductor. So what should this net effect be? Zero. The net electric field at P must still be zero no matter what. So this has to be zero. Now, these are three vectors. Together, at P they are adding up to 0. Together they are adding up to 0. Now, at P, these three vectors, electric field because of plus q, this and this is one way that they could add up to 0. See, they are aligned and assigned in a manner that these three vectors add up to 0. All together add up to 0. But again, nature has very stingy ways of doing things. And the way they add up to 0, again, for the time being, I will not get into a formal description of that. But let me tell you, these three vectors add up to 0 in a very peculiar manner. These three vectors add up to 0 in a very peculiar manner. The manner in which they add up to 0 is not a 3. This would have been a three-way cancellation. This would have been a three-way cancellation, right? this would have been a three-way cancellation. That means, eventually these three vectors would constitute sides of a triangle taken in order. That's a three-way cancellation, producing zero net effect. But this is not how it happens. At P, the electric field doesn't become zero because of a three-way cancellation. What really happens is it's only a two-way cancellation. This does not happen. This does not happen. DNH. This does not happen. What happens at P is the following. At P, E, because of plus Q on the outer surface, is independently zero. E at this point P, because of plus Q on the outer surface, will be independently zero, and E, because of plus Q inside the cavity, plus E, because of minus Q on the cavity walls, separately add up to zero. Separately add up to zero. Let me tell you what happens at P. This charge, which is on the outer surface, independently produces zero electric field at P. And I have not given you proof for that, right? And the cavity and its contents, this is the cavity and its contents. What would you look upon the cavity and its contents? The charge inside the cavity and the charge on the cavity walls. These two connive together to produce zero electric field at P. Separately, this Q and minus Q produce zero electric field at P, and the charge on the outer surface of the conductor independently produces zero electric field at P. So it's not a three-way cancellation. It's not a three-way cancellation, it's only a two-way cancellation. It's only a two-way cancellation. The charge on the outer surface all by itself produces zero electric field at any point P inside the conductor, and outside the cavity and its contents independently together will come together, will produce zero electric field. Just make a formal note of it. For any point P, be it in the meat of the conductor or outside the conductor, electric field produced by the cavity and its contents, will always be zero. Which means, even if this point P was outside this, then the cavity and its contents do not distinguish between points in the meat of the conductor or points outside the conductor. They will produce zero electric field everywhere. Now, write down. If the point P was inside the conductor, in the meat of the conductor, then the leftover charge on the surface of the conductor, on the outer surface of the conductor, charge on the outer surface of the conductor will produce zero electric field at that point. hey, so 1, if there is a point P here, then the electric field because of the cavity and its contents will be 0. If there is a point P here, then the electric field because of the cavity and contents will again be 0, right? Now, if there is a point here, then the electric field because of this will be 0. But if there is a point P here, the cavity and its contents will produce 0 electric field at P, but the net field at P will not be 0. The charges on the outer surface of the conductor will produce the net electric field at P. The net electric field at P will not be because of the cavity and its contents, but will be because of the charge on the outer surface of the conductor. Which means the charge on the outer surface, how it safeguards the proposition inside the cavity, because you know, if you were an observer to be observing the electric field at P, you would not know what is happening inside the cavity. All that you would want to believe is that the electric field at P is being caused only by the outer surface. Such is the distribution happening on the cavity walls. Their communication to the outside world, electrical communication to the outside world, for all points outside the cavity is shunya. They have no communication with the outside world, right? So if there is a charge plus Q kept here, it will experience no force because of the cavity and its contents, because the cavity and its contents will produce 0 electric field at P. The net field at P will be only because of the charge on the outer surface of the conductor. You know what I'm saying? Clear? Now, so then, one thing, for every point P, this charge plus Q has got distributed in a manner that for any point P, the electric field is 0. How should the charge distribute itself? Inversely proportional to R. The charge plus Q, the leftover charge plus Q, distributes as sigma inversely proportional to R, because that's a distribution that could cause 0 electric field everywhere. That's the only proposition that could cause 0 electric field everywhere inside the meat. So not just in the meat, this charge on the cavity walls is causing 0 electric field not just in the meat but also in the cavity by itself. Sigma inversely proportional to R in this entire region will cause 0 electric field. But in this case, the meat of the conductor continues to be 0 electric field because of two factors. Cavity and its contents 0 electric field at P, and the charge on the outer surface is sigma inversely proportional to R, that is also 0 electric. However, if you look at a point P inside the cavity, then this sigma inversely proportional to R will produce 0 electric field at P. But the cavity and its contents will produce non-zero electric field at P. The electric field at P, for example, would be like this. There is a non-zero electric field in the cavity this time. E inside the cavity is non-zero this time. The outer surface, charge on the outer surface is sigma inversely proportional to R. That has caused 0 electric field inside the cavity. But this plus Q and minus Q will produce electric fields like this, yes or no? Will produce an electric field like this. Therefore, there is a non-zero electric field inside the cavity. There is a non-zero electric field inside the cavity this time. If there is a charge inside the cavity, the net field inside the cavity will be non-zero. It is because of two things. One, charge on the outer surface will produce 0 electric field everywhere inside the cavity and in the meat. But this plus Q and minus Q, the cavity and its contents together will synergize to produce non-zero electric field inside the cavity, will produce non-zero electric field inside the cavity. But outside the cavity and its contents remain shielded. You cannot make predictions about what is happening inside the cavity. You know what I'm saying? It is protected, safeguarded, closely guarded, right? The cavity and its contents are an electrical secret to the outside world, right? Now, হ্যাঁ বলছি, এই দেখ, যে কোনো একটা পয়েন্ট ধর ক্যাভিটির মধ্যে, হ্যাঁ, এই চার্জ ডিস্ট্রিবিউশনের জন্য ভেতরে ইলেকট্রিক ফিল্ড সব জায়গায় জিরো হবে, হবে তো? কিন্তু লুক এট দি ইলেকট্রিক লাইন্স অফ ফোর্স, এই ক্যাভিটি মালটা দেখ, এইখানে একটা চার্জ বসে আছে, এইখানে ক্যাভিটি ওয়ালসে মাইনাস কিউ বসে আছে, কেমন? সো would you not expect electric lines of force from the positive to the negative charge? These are radially outward electric lines of force from positive to negative charge. Non-zero হচ্ছে না? Two-way cancellation ক্যাভিটির বাইরে, ক্যাভিটির বাইরে, ক্যাভিটির ভেতরে না। ক্যাভিটির ভেতরে এইখানে যদি চার্জ থাকে ফিল্ডটা ক্যান্সেল হবে না, শুধু বাইরের সারফেসের জন্য ফিল্ডটা জিরো হয়ে যাবে ক্যাভিটির মধ্যে, কিন্তু ক্যাভিটি অ্যান্ড ইটস কন্টেন্টস ভেতরে নন জিরো ইলেকট্রিক ফিল্ড প্রডিউস করছে, বাইরে ইলেকট্রিক ফিল্ড প্রডিউস করছে না, সো দ্যাট নোবডি ক্যান নো অ্যাবাউট হোয়াট ইজ হ্যাপনিং ইন দ্য ক্যাভিটি। ক্যাভিটি কন্টিনিউস টু রিমেইন আ পাজল টু দি আউটসাইড ওয়ার্ল্ড, রাইট? Now see inside the cavity, so just look at the cavity. If the charge q was moved in, this was the charge and there was a certain non-uniform charge distribution on the cavity walls, there was a non-uniform charge distribution on the cavity walls, right? And there was a leftover charge plus q on the outer surface of the conductor. Now if I were to fiddle with the charge inside the cavity, if I were to fiddle with the charge inside the cavity, okay, if I were to move this charge inside the cavity, what would happen is this charge on the cavity walls minus q will redistribute itself. This charge minus q on the cavity walls will redistribute itself so that its communication to the world outside the cavity remains preserved, or rather its lack of communication remains preserved, because this redistribution would be commensurate with the fact that this q and the new distribution, this new position of q and the new distribution on the cavity walls together connive to produce zero electric field everywhere outside the cavity, be it a point p in the meat of the conductor or outside the conductor, right? So any movement, any change inside the cavity is not going to alter the distribution on the outer surface of the conductor. Any distribution, any change inside the cavity will be compensated by a corresponding change on the cavity walls alone, will be compensated by the corresponding change on the cavity walls alone, preventing any change on the outer surface of the conductor, so causing the net electric field outside the cavity owing to the cavity and its contents to remain zero at all times. Yes or no? So if this charge is moved, then its brother, the charge on the cavity walls, will take care of the corresponding changes to still produce zero electric field outside the cavity, right? And this movement, will it alter the charge on the outer surface, charge distribution on the outer surface? No, it will not alter the charge on the outer surface. What will it alter? It will only alter the charge distribution on the cavity walls. Is the idea clear? Similarly, if I were to immerse this in an external electric field E naught, if I were to immerse this in an external electric field E naught, then this q, which was as per sigma inversely proportional to r, realigns, redistributes to produce zero electric field everywhere inside, right? If an external electric field E naught was applied, it is only the charge on the outer surface which gets redistributed, keeping the cavity and its contents virgin, right? It will not change. This external electric field or presence of an external charge q will only alter the charge on the outer surface, will not do anything to the cavity and its contents. Any changes inside the cavity will not do anything to this charge distribution. Any influence coming from outside the conductor will not change the looks of the cavity and its contents. Yes or no? बोलो, confusion है क्या? Stand by. Can reside in the meat of the conductor. 2. Under electrostatic conditions, the meat of the conductor offers a region of zero electric field. Now, there are times that these electrostatic conditions might take say 10 to power minus 12 seconds or 10 to power minus 20 seconds to be attained, you know. They look like almost instant, but yes, the meat of the conductor, if exposed to an electric field for some time, there would be a current flowing through that meat. Okay, but again, under electrostatic conditions, electric field will be 0 in the meat of the conductor. If there is an isolated charge q given to a conductor, that charge q will find residence only on the surface of the conductor. It will get distributed on the surface in a manner that the net electric field in the meat of the conductor is 0. The only way that a distribution can produce 0 electric field in that region is if sigma is inversely proportional to radius of curvature. 1. 2. If there is a conductor and it's exposed to an electric field and there is a cavity inside that conductor, then charges on the outer surface will realign, redistribute to annul the effect of the external electric field, and therefore to once again restore 0 electric field in the meat of the conductor and inside the cavity. If there is a charge inside the cavity, this is a conductor, there is a charge q inside the cavity which induces a charge minus q on the cavity walls, leaving you with charge plus q on the outer surface, then the important thing is 1, the cavity and its contents. See, this distribution on the cavity walls, if this is an irregular surface, then this distribution on the cavity walls will be non-uniform, and this distribution will occur in a manner that this plus q, this minus q, they will communicate to produce 0 electric field everywhere outside the cavity, be it in the meat of the conductor or outside the conductor. This charge plus q will distribute itself on the conductor, outer surface of the conductor. This is the what I have called the leftover charge or the compensating charge. Will distribute itself in a manner that at every point in this region, which includes the cavity region also, the electric field will be 0. This will be a region of constant potential. If there is a charge inside the cavity, then the cavity is a region of non-zero electric field. E will be non-zero. Electric field lines will be like this, from plus q to minus q. If the charge inside the cavity is transported inside the cavity, right? Now, by no means did I mean that a conductor cannot be charged. You know, this was an uncharged conductor. Let's say there was a charge only inside the cavity, but no charge. But if I give it a charge plus q, where will this charge q go? It will again distribute itself. Now, instead of being plus q on the small q, it will be capital Q plus q on the outer surface. And this plus q, capital Q plus small q will distribute itself as sigma inversely proportional to r. That is what would happen. Now, any realignment of this charge q inside the cavity will only change the configuration of charge distribution on the cavity walls to produce 0 electric field everywhere outside the cavity. It does not distinguish between points in the conductor or outside the conductor. But the charge small q, which is the leftover charge, will be as sigma inversely proportional to r. It will produce 0 electric field everywhere inside this, including the cavity, all by itself. If an external charge is, if a charge capital Q is kept outside, it will produce an electric field. Now, that electric field, because of plus q, will cause these outer charges to get realigned, redistribute, so that the net electric field at any point, which was now the unbalanced field produced by plus q, will be cancelled by the new distribution of charge on the outer surface. You know what I am saying? So, any changes outside the conductor will be completely managed by charge on the outer surface of the conductor. Any changes inside the cavity will not affect this distribution on the outer surface of the conductor. That's the key thing. That's the key thing. You know what I'm saying? Now suppose, so far so good, right? Suppose there is this charge Q and this is the conductor. The cavity is spherical. The cavity is spherical. Spherical cavity, right? It will induce charge minus Q on the cavity walls. It will induce charge minus Q on the cavity walls, leaving plus Q on the outer surface. Leaving plus Q on the outer surface. Q is at the center of the cavity, spherical cavity. Q is at the center of the spherical cavity. Now, one thing, will the charge on the outer surface be uniformly distributed or non-uniformly distributed? Non-uniformly, it has to be as per sigma inversely proposed. So this is NU, non-uniform. Alright. Now, what about the charge on the cavity walls? Will it be uniform or non-uniform? Uniform, because yes, this is spherical. No, it's not as per inversely proportional to R, Gurudev. This time, look, for points outside, this minus Q and this plus Q would have to produce zero electric field. See, what I mean is, look, this is a point P anywhere outside the cavity. P could be in the meat of the conductor or outside the conductor, right? This plus Q will produce an electric field like KQ by R squared here, right? Now this minus Q should produce like a KQ by R squared to the left in this direction, right? How can this minus Q at a distance R from the center produce a KQ by R squared? If you can imagine this minus Q to be at the center, when can you imagine this minus Q to be at the center? If this was a uniform distribution of charge. If this was a uniform distribution of charge. समझ गए? देखो बेटा, ये cavity and its contents है. Just look at the cavity and induce charge on the cavity walls. Induce charge on the cavity walls. Minus Q induced. ठीक है? Now, how should the cavity and its contents communicate with the outside world? They should produce zero electric field everywhere outside the cavity. Okay? So सोचो ये Q center पे है, cavity के center पे है, spherical cavity है. Now at a point distance R from C, what's the electric field produced by Q? KQ by R square. That's the electric field produced at P. Electric field at P produced by plus Q is KQ by R square, right? Now electric field at P is because of electric field of plus Q plus cavity walls wala plus Q, E because of plus Q due to the cavity walls, minus Q because of the cavity walls, right? Together they must add up to 0. That means E because of minus Q should be like minus of E because of plus Q. That means at this point, the electric field at P produced by minus Q must be like K times minus Q by R squared. So that this K times minus Q by R squared and this K times Q by R squared cancel off at P. Nahi. This is what I want, na? Now, that means this charge distribution produces from the center of the sphere a field by itself which is K times minus Q by R squared. That means I could have imagined this minus Q to be at the center. I could have imagined this minus Q to be at the center. When can I imagine this minus Q to be at the center? If this minus Q is uniformly distributed on the cavity walls. If this minus Q is uniformly distributed on the cavity walls. That is when I can imagine it to be at the center. This is, it does not matter. It does not matter. Inside the meat anyway 0 है. So net, तो ये vacuum ही है. Essentially ये vacuum ही है. Because of, how does it matter? Eventually it is in air. It does not matter. You saying देखो ये जिसके कारण k effective k इसका infinite k हो जाता है 1/4 pi epsilon naught epsa r, ये इसका effective k will produce zero electric field. उसका तो that's a net effective k in the meet that will produce zero electric field. Anyway zero ही हो रहा है वो, but वो तो superimpose करके ही हो रहा है ना. Now the other thing is, please. So if a charge q is kept here, this distribution would be non-uniform. Now if I move the charge from the center to some other point, will this distribution still be uniform? No, it will be non-uniform. This will become non-uniform. Clear? Can I wipe this off? तो इसीलिए तो नॉन यूनिफॉर्म होगा, क्योंकि अगर ये यूनिफॉर्म होता, then I could have imagined this minus q to be at the center. It would produce k times minus q by r square here, but this q here is not producing k times q by r squared, right, if moved from the center. So then it will not cancel off. So this has to be now non-uniform if this q is moved. This has to be now non-uniform charge. Suppose okay, answer this question. There is this conductor, spherical conductor, but a non-spherical cavity. Charge q kept here. Spherical conductor but non-spherical, non-symmetric cavity. Charge q here. ठीक है? यहाँ पे charge क्या हो जाएगा? Minus q. What would be the leftover charge here? Plus q. Okay. Now, will this plus q be uniform? Yes. It has to be sigma inversely proportional to r, and r is the same. So this q will get uniformly distributed. Will this minus q be uniform? It will be non-uniform. It will be non-uniform, right? So this will be uniform, and this on the cavity walls will be non-uniform. Will be non-uniform. ठीक है? You understand this idea? Not a problem. And if suppose the spherical conductor, charge q at the center, cavity at the center, both spherical, this is at the center, then this will be uniform minus q, right, if it is at the center, and this will be also uniform, yes or no, plus q. This is uniform and this will be uniform, right? Now if this charge is moved, what will happen to this? This will become non-uniform and this will remain uniform. नहीं समझे? समझ गया ना? नहीं समझे तुम? बोलो 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 কি বলছিস গাজার কথা নাকি মজার কথা one of the things, and it's a, you know, there was this guy who was heading Tata Steel at one point of time in Jamshedpur, and was also the director of IIT Kharagpur when I was a student. And he was known to be the most successful impresario, most successful manager in the entire world at that point of time. His name was Rusi Modi. Okay. And it is important for you guys to understand this, and for you especially. You know, he had one strength. He could make fun of himself, and he could tolerate fun made on him. While he was very humorous with others, he could, you know, crack a joke on anyone else, but he was, you know, very hearty when a joke was made on him, when lighter remarks were passed on him. He could take it in a lighter spirit. All right. I hope you get my message. You seem to get very antsy when, you know, there are lighter remarks made on you, whereas you are, you know, in a certain sense, very liberal about talking related to others. But when it comes to you, you know, you immediately respond with a lot of arrogance. Avoid that. It will not make sense. They are your friends. They're not really making fun of you. They're having fun with you. Okay, don't look upon this like making fun of you. They're having fun with you. So don't carry things that far. Yes.